This session is around how to build runtime applications using, in this instance, the Java SDK. I'm Mark Baird, and I'm joined with my colleague here, Tyler, and we're both members of the Runtime for Java team. Now, before I get going, I just want to get a feel for who we've got in the audience. So, have we got anybody here who are currently ArcGIS Engine developers and they're looking to convert over to the runtime? No ArcGIS Engine developers. That's encouraging. That's good. So nobody's using the old technology. What about people who are completely new to the Runtime SDK? Is anybody? We've got a few, probably maybe about half of you there. So okay, and people who are using the version 10.2.4 of the SDK. There's a few of those. And anybody who's using the version 100 yet? Just one. Okay. Well, I think we've got a good set of slides here to keep you happy. So, in this session, we're going to be focusing this on the version 100 of the SDK. It's a little bit different to the version 10.2.4 that was previously out there. One of the big things that we changed was that we've introduced JavaFX. So we'll be sort of talking you through some of the things you'll come across when you're working with that. Now in the session we're actually going to be going through and introducing you to the new classes you're going to be working with version 100. It has changed a little bit, so the JMap that you may be familiar with has gone away, so we're going to be telling you all about the new classes you'll be working with. I'll also cover a little bit around the subject of offline data. Now, I'm not going to dive into this in a huge amount of detail because there is another session on this which you could attend, but I just want to give you a feel for the capabilities that are available for you if you're wanting to write applications that are offline. We've got some news about local server, which has actually been separated from the Java SDK, so I just need to tell you a little bit about that. And we'll talk about graphics overlays, so if you want to be able to draw very fast rendering points on your screen in sort of a real-time display, we'll take you through an example of that. And then we'll finish off with how to license and deploy your application so you can get it to market and maybe start making some money out of it. And then we'll take questions at the end. Okay, so if you're starting with the SDK, a very good place to begin with is the developer's website. So I'm going to switch over to just take you for a very brief tour of that. So it's a website that, if you're familiar with it, is actually changed in the last few days. So we've sort of rebranded it a little bit for the Developer Summit. And all of the SDK documentation is there across the board. So we've got JavaScript at the top there, and we'll move down to Java. This is what we're interested in. So the landing screen here has got, bits of marketing information that can tell you what the SDK is capable of. But the thing that you should be interested in is the guide documentation. And what we've tried to do here, we've tried to think of common use cases that you as developers are going to be implementing in your applications. And we've tried to make step-by-step guides so we can take you through the process of implementing that area of functionality. So if you do feel that there are gaps in that, then do come and do talk to us, and we can try to sort of get some more example items of documentation there. We've also got the API reference, so this is the Java doc that comes with the SDK, so this is just an online version of that. We've also got a large number of samples that we've written, and these are all hosted in GitHub. And again, these are aimed to cover common use cases that you'll be implementing. So Tyler will talk us through that in a moment or two. And if you've got any questions whilst you're developing, there is an online forum, so we're sort of there to help answer questions there. And there's a number of other people in the community who use the SDK who seem to jump on it. There's people who spend far too long on this forum, but that's a good thing. That helps us. Right, let's just move back to my slides. Okay, so version 100 is it's a little bit different in that when you get hold of it, if you're using 10.2.4, you'll be familiar with that there was a setup application for it. That's actually gone away. We've actually sort of modernized the way in which we deliver the SDK now. So it's available in one of two ways. So to support people who work in sort of more traditional methods and they like to get hold of their jar files physically and wire it up with their IDEs, we do have a zip or tarred gunzip file that has got all the required files, so you can sort of wire these up inside your IDE to deploy your application. But going forward, we've actually started to deploy the SDK in a Maven repository. And what this allows you to do is to use Gradie for dependency management in your applications. And we've also got a Gradie and a Maven plugin that will enable you to bring into your application, into your IDE, the other files that you require to run the application. So you have to remember that we're not writing pure Java applications here. The Runtime SDK for Java is built on a C++ core that we need to have present when you're deploying your application. So we're using a JNI link into those libraries. So just very briefly looking at Gradie, which I would recommend going forward if you want to build new applications. I'm not going to go through and teach you how to do Gradie scripting. That's obviously a very large subject, but I'll just sort of give you a highlight of the items that you will want to put into your Gradie script. So the first thing that I've got here is a reference to the Maven repository that contains the jar files that you'll need to inject into your application. So you can see here that we're actually storing that in a repository called esri.bintray.com, and it's actually stored alongside the Android SDK as well, because obviously they're very keen on using Maven scripts. And I've also got a reference here to the plugin that will help to bring across the other files, the other dependencies like the libraries for the runtime core that you need to have alongside your Java applications in order for them to be able to run. Now, the plugin actually brings across all of the files. So these are the binaries for Windows, Linux, and Java. So when you first run your Maven script, you may find it takes a few seconds for it to just bring all the files across the first time you run the script. So do be patient with it if you haven't got a very fast network connection. Okay, the other thing that we've changed in version 100 is we've introduced JavaFX. So JavaFX, it's been around for a few years now, but I think with Java 8 that came out fairly recently, it really has come of age. I mean, you could be forgiven to say that some of the earlier versions of JavaFX were a little bit ropey, but it's actually a pretty solid UI platform now. So we've actually built our components as JavaFX 8 components, which will allow you to be able to write much more modern style looking applications. Swing that we've used previously is very old, and you have to sort of put an awful lot of effort into making an application that looks fairly modern for modern operating systems. Now that in turn will allow us to be able to produce a much better toolkit. So if you remember at Swing, we had various widgets that you could put into your application. Well, we haven't actually written those in JavaFX, but we're in the process of doing that. So that will be available over the next couple of releases that we're putting together. And these do look much nicer than the old style Swing applications. And also you as Java developers will be able to make use of some of the new Java 8 concepts out of there. So you'll be able to dabble in things like lambdas and streams, the new concepts that are coming out in Java 8. Now, one thing you do need to be aware of is that we're not planning on supporting Swing in version 100. Now, this is actually in line with what Oracle are doing. So Oracle are no longer developing their Swing components, and they're pretty much parked, and the team is pretty much disbanded. Now, obviously, that's going to raise the question, if you're already Swing developers, well, yeah, how do I move from Swing to JavaFX? Well, there are solutions out there. So I will acknowledge that you can put Swing components into JavaFX apps. I don't know why you'd want to do that, but you can. I think probably more likely is that you might consider putting a JavaFX component inside an existing Swing application, so you can sort of smooth the transition process if you're migrating your applications. Now, This is a subject which is fairly hotly discussed at Java 1, and a lot of people actually consider this to be a bad idea. It's not necessarily bad. You just need to be aware that the Swing and the JavaFX frameworks both run on different UI threads. So you just need to make sure that you're not sort of you're not trying to update a JavaFX component on the Swing thread. You just need to sort of wait to make sure that you're calling back on the right thread. And if you don't do that, you may get yourself into a situation where your application is not particularly stable. It might not respond. It might even crash. So it's just something you just do need to be careful of. People say don't be tempted to mix the technologies. I mean, in an ideal world, if you're writing Swing applications, 10.4 is a very good technology, and we are still supporting that going forward. If you're writing JavaFX applications, then version 100 is what you want to use. But you can mix and match the technologies, but just be careful about your UI threads and you won't go too far wrong. Okay, so just thinking about the new structure of the SDK. So those of you who are using version 10.4 will be familiar with the JMap class that we had. So this is like the Swing component that you built your applications up upon. Now we actually had feedback that the structure of this class was not particularly well suited if you wanted to write yourself model view controller style applications. And as JavaFX is very much geared towards writing those style of applications, we've actually sort of broken this high-level class down a little bit. So at the top level, you'll be working with two classes. Now, the first of which is what we call the map. Well, actually, we decided in Java map was probably a bad name for it because that might clash with something else that you're working with on a fairly common basis. So we called it the ArcGIS map, but in other runtime SDKs, it might be called a map. So what the map contains, it defines the layers information you want to visualize inside your application. So you define the base map, which specifies the wallpaper for your application, and then you can add your operational layers on top of that. So your operational layers are things like feature services, that data that you've stored in ArcGIS Online or your own ArcGIS server. Now, to visualize that, you need to make use of the map view class. So this is the JavaFX visual component that you're putting inside your application. And you just need to associate the two together to be able to visualize all of the information in your application. Now, at version 100, we also introduced the 3D capabilities. And actually writing 2D applications and 3D applications is really similar. So rather than working with a map, you're going to be working with a scene. Well, unfortunately, scene was another unfortunate class name that clashes with JavaFX developers. So we actually call this an ArcGIS scene, just so that you don't have to fully qualify your classes and have horrible looking code. Now your scene is just like a map. It specifies the things that you want to visualize inside your application. So we've got a base map and operational layers, exactly you have to in a map. But with 3D applications, you also have the concept of adding a surface. So a surface basically enables you to be able to bring in a terrain so you can see the lumps and bumps of mountains if you wanted to visualize things in 3D. So rather than, when you're displaying your 3D map, so rather than using a map view, you're going to be using a scene view. And just like in a 2D application, you just associate the two together so that you automatically display the 3D data in this case. So I'm going to hand you over now to Tyler, who's going to talk you through building up a basic application and looking at samples too.
All right, thanks, Mark. So to demonstrate adding layers to a map, I have open one of over 50 sample applications we have available on GitHub. The samples come in a variety of categories with topics ranging from simple single feature use cases all the way to complete end-to-end workflows. So for this sample, it covers adding feature layers from a feature service. It's a very basic JavaFX application. In the start method, I'm creating that map view control that Mark was talking about and adding that to the application window. Then I'm creating an ArcGIS map, specifying one of our default base maps. And I'll set that map to the map view. Now at the top, I have a URL to a feature service. I'll use that to construct a service feature table. This is what's used to actually update features in that service. And I can construct a feature layer with that table. And now I want to render that feature layer above the base map. So I'll add that as an operational layer to the map. And now each layer has its own loading state. And we can add listeners to be able to look at that state. So when I call load async on the layer, I can attach a done loading listener with this nice Java 8 Lambda expression to check that the layer successfully loaded. And if that's the case, I'll set the viewpoint of the map to the feature layer's extent. So I'll go ahead and run that. And you'll see that it starts up and immediately zooms into the layer's extent. This layer is made up of lots of little pieces. Down here in the corner, you can see that layer loaded. So if I close this and go back to the code real quick, I just want to demonstrate that if I mess with this URL a little bit, now I can expect the layer to fail to load. So in that case, in my done loading listener, I've decided to print out that error. So if I run this again, you'll see that the application still runs, and there's no way to detect from the end user's point of view that there was a problem. And if I go ahead and close this, see in the console the error that occurred. So that's the basics of adding layers to a map. I'll hand it back to Mark to talk a little bit more about this loadable pattern.
Yes.
So you'll actually see the loadable pattern in quite a few places of the SDK, and this is typically when you're working with things that are not necessarily going to respond very quickly. So you want to be able to sort of wait for a result to come back, but you don't want to do that on the UI thread and hang your application. So this loadable pattern, it's on the feature services, it might be on tiled services that you're working with, it may be on portal items that you're working with. So in the example that we're looking at here, Tyler was creating a feature service and a feature service table it was, and when he first instantiated that, it was in a sort of a not loaded state. And then when he started using that, so he called a load async method, that went into a loading state. So it's going off and it's talking to the server and it's trying to sort of get the connection together. And then he set up listeners so that he could detect when the loading status had changed. So when he got the URL correct, it landed into a loaded state. And in your application, what you could do there is you could do something which is relevant to allow the user to interact with that feature service. So you might turn on some sort of an editing toolbar that would enable you to start sort of digitizing new points. But if something went wrong and the network connection wasn't work, or you simulated this by changing the URL, it would actually load into a state which is failed to load. And that you could give your user some feedback at that point to say, there's something wrong here, you need to check your network connection, or talk to your administrator to say that the service is down. You could fix the link, and then you could actually sort of call it again, sort of, oh, have another go. I might have sort of discovered that the network cable had not been connected in my machine, and in which case it would go back into the loading state, would have another go, and if you're lucky and you've got a good network connection, it would land into the loaded state. So this is a pattern you'll see all over the SDK. Okay, so as well as data that you can bring from online sources, we also recognize that you may be wanting to write applications that are working in an environment where you don't have any network connectivity. This is actually very common for mobile devices, but people want to be able to sort of take laptops out into the field to do field data collection. Now this is something that we do support, and there are two high-level patterns that we offer for this. So the first of which is what we call the services pattern. So this is where your data, your feature data may exist in ArcGIS Online or your own ArcGIS server. Now if you configure that feature service so that it's what we call to be sync enabled, when you're connected to it, what you can do is you can request the feature service to create you an offline version of that data. And normally what you do is you just sort of pass in an extent of the area that you're wanting to work in when you're offline, and you send that request off to the server and say, make me an offline geodatabase. And then the server will create that and you'll download it so that it's stored on your device. So when you fire up the application, when you don't have any network connectivity, you can just connect to that geodatabase and be able to view and edit your data when you're offline. Now when you finish doing your field data collection and you're back in an environment where you do have a network connection, you can actually synchronize the changes back. Now this is a two-way process. So not only are you going to be uploading to the feature service the new features or the edits that you've been making whilst you've been offline, it'll also download the changes which other people have been making to the feature service in the area that you've actually been working in. So once that process is completed, you've got a completely up-to-date offline copy of the database that you can then take into an offline environment for another day's worth of field collection. Now the other pattern that we support is for users of desktop. So the desktop tools enable you to be able to create runtime content. So you can create your data in a geodatabase format, it's actually the same geodatabase format that you create from ArcGIS server, but this is just for read-only purposes. So this is just to visualize the data. So there's no update cycle you can actually achieve here. So there's just another workflow that we support for people who don't necessarily use the ArcGIS platform. Okay, well, as well as feature data, there's a whole host of other data formats that you can use in an offline environment. So we've already talked about the geodatabases, which can come from your feature services or from ArcMap. Obviously, you're going to need your background mapping, your wallpaper, so you can get yourself offline tile packages on your machine. So again, you can go to a tiled service and request it to download the tiled area that you're interested in, or you can generate these with ArcMap as well. We can also support offline vector tile packages, which you may have sort of come across. We've been talking about that. So these are nice because they're nice and small and you can rotate them and the labeling sort of rotates on them as well. The advantage of those is that they have a much smaller footprint on the machine that you're working on. So tiled services are colossal, but vector tile packages are a fraction of the size. We've got mobile map packages which contain potentially all of the above, so it's a single package that you can put onto your machine. We've got scene layer packages which enable you to be able to view 3D scene services, so this is where you can visualize the 3D geometries that make up buildings which are sort of nicely textured in a scene viewer. And then we also continue to support the map packages which may have been used in local server in the past. Now, although we do continue to support map packages, I would discourage you from using those in local server because all of the formats above that are a much better modern way of doing it, and they enable you to be able to synchronize your data. So if you're writing new projects, then I would discourage you from using the map packages inside local server. So coming on to local server, you may have noticed if you download version 100, it's the local server's not there. Oh, that's a bit alarming, but don't worry. It hasn't gone away. It still has a sort of a very valid use. But as I explained, I see it being used less for visualizing data, and the operations like geocoding and routing and the offline data formats that we previously supported in local server, those have been replaced with much sort of modern and more efficient offline packages. So you don't want to be using it for that ideally, although we do still support it. The reason that local server stays with us as a separate download is for geoprocessing. It contains the capabilities to run very rich geoprocessing tools that you can sort of use inside the toolboxes in ArcMap. And a lot of that functionality is never going to find its way natively inside the runtime, because we don't want to bloat it and make it sort of a massive product. You know, we can leverage that from using the local server. As I say, it's available as a separate download, and as before, we support that in Windows and Linux environments. But unfortunately, the architecture of the Mac operating system is such that we don't support local server on Mac. That's not something that we've got in our roadmap, but if it does present anybody with any major problems, then do give us some feedback. So it is only available for Windows and Linux local server. So just to give you a flavour of how to use some geoprocessing inside local server, Tyler's just going to give us a demonstration of some code he wrote earlier.
All right. So for this demonstration, I want to show you how to do some basic geoprocessing with the local server. So here, this is also from a sample in our on our GitHub repo as well. Here I'm creating a local geoprocessing service. I do that by passing in a path to a local geoprocessing package. And I want to handle those requests asynchronously, so I set that service type. This local service exposes a task to create elevation contours. So that's the kind of geoprocessing we'll be doing. Here I'm starting the local server if it hasn't already been started. And when that's ready, I start the geoprocessing service that I created earlier. I also attach a listener to enable a button when that geoprocessing service is ready. So I'll go ahead and start this application just to show you what it looks like before I go into the details of creating the contours. So when I start it up, you'll see some loading. That's the geoprocessing service starting. If I specify an interval here, this will control the separation of the contours. I can submit the job, and it will generate the contours with the service. And when it's done, I get a new layer with the elevation contours on my map. So if I go back, I can go down to the method that's called when that button is clicked. Here I'm creating a geoprocessing task specifying the contour task that I want. And now that contour task requires a parameter for the interval between them. So for that, I'll create some geoprocessing parameters and pass in the value from that text field. And now I'm ready to create the actual geoprocessing job that I'll send to the server. I create that with the task, passing in those parameters. And this is all done asynchronously, so I'll add a listener to do some work when that's ready. When it's succeeded, I'll use the job ID of that geoprocessing job to get the resulting map image layer from the server, and then I'll load that and add it as an operational layer to the map. So that's the basics of doing some geoprocessing with the local server. I'll go back to Mark and he'll talk about some more advanced capabilities.
So again, you know, Tyler was working here with an operation that took a few seconds to operate. So note the use of the loadable pattern. This is the asynchronous pattern that is all over the SDK. Okay, so I'm not going to talk about analysis in a huge amount of detail. If you're more interested in analysis, on Thursday afternoon at 4 o'clock, there is a whole session dedicated to analysis. But just to give you a flavour, the tool that we were looking at here was part of a set of pre-built tools that are inside the ArcGIS system. There are hundreds of these tools available, so you can do things like proximity analysis or spatial analysis or view shared. I mean, the list is sort of extremely long. There is if you look in our website, there is a list of all of the supported tools inside the ArcGIS Runtime. So that's a subset of the tools that are available in ArcMap. So not all of them are supported, but there are several hundred of them that we've got in there. So you can actually build up your own using Model Builder or Python inside ArcMap, and you can make these available so that they're either published in ArcGIS Server, or in the instance that we were looking at here, we wanted to be able to run our geoprocessing whilst we were offline. We were sort of working with a geoprocessing package that was ready-made in ArcMap in this case. And it's, just a case of using our task-based framework in the API to be able to pass your parameters in and get a result that you can visualize inside your applications. Okay, so just sort of moving on, another area which is commonly used in our SDK is graphics overlays. Now, those of you who worked with 1024, you'll be familiar with the graphics layers. So effectively, the graphics overlays are just a renamed equivalent of this. And these are typically used for displaying temporary data or fast-moving data. So this kind of data could be coming in from a radio feed. I don't know, you might be sort of tracking all the taxis in your taxi company, and you've got this information being fed in, all the updates are coming into your machine through a sort of radio equipment. Now, you're not going to write that information into a feature service because there'd be too much traffic, and the database would be sort of brought to its knees by the sort of the constantly updating feature service. So you're just going to be maintaining this data inside your own application. So you're maintaining that in memory yourself. Now, the graphics overlays can be used to represent point data. So, typically that's the most common. So we're trying to locate the location of things that we're tracking. But you can also use it to draw lines and polygons. And the rendering techniques for these points, lines, and polygons are exactly the same rendering techniques that you use inside feature layers. So if you're familiar with different symbols and renderers, then you'll be completely at home in actually drawing these things. Now, in terms of the class structure, you'll notice that the graphics overlays are not part of the map or the scene. They're actually associated with the map view or the scene view. And the reason we've done that is that the data is not persisted. It doesn't come out of a map. A map could potentially be inflated from a portal item, a web map that you've got on ArcGIS Online. So the graphics overlays, because you're responsible for the content of the data in there, are associated with the ArcMap, with the map view. Oops. Okay, so in terms of draw order, when you're rendering things in your application, the base map will be drawn on the bottom, and on top of that you'll have your operational layers, and because graphics layers are the most important thing, we render those on top of everything else. So we've got an exciting demo from Tyler now, with a 3D application showing you graphics overlays.
Right. So instead of showing you another sample, I wanted to highlight some of the basically a hint of the more advanced capabilities and performance of graphics overlays. If you've been walking through the showcase, you might have seen the demo on the screen of satellites going around the Earth in 3D. So that was a small JavaFX application that I wrote. Here I have a satellite model class for each of those satellites. This contains some orbit data as well as a graphic for each satellite. If I go to where I'm creating the graphic, I'm using a distance composite scene symbol. Those allow you to change the appearance of the graphic based on how far you are away from it. So when I'm closer, or when I'm farther away from the graphic, I am using a red circle symbol as well as a text symbol showing the name of the satellite. And then when I'm closer in, I've actually selected that satellite. I want to show a full 3D model of the satellite. So I can do that with the distance composite scene symbol. And to create the actual graphic, I'll give it an initial position and pass in that symbol. if I go to the controller here, you can see that after I've loaded the satellite data, I go ahead and do a stream to get those graphics from each satellite, and I'm just passing them into a graphics overlay, which is on my scene. To animate those graphics, I'm using a standard JavaFX timeline animation, where each 20 milliseconds, this animate method is called. When that's playing, I'll go to the animation method here. All I'm doing is just looping through those satellites and getting their graphic and updating their geometry to the new position for that frame. So I already have it running up here, and you can see the performance is pretty good for just looping through each of those. As you can see, the symbol for far away is that red circle with the text symbol, and if I press a shortcut key, I can switch over to the Hubble Space Telescope, showing that full 3D model symbol. So that's a highlight of some of the more advanced capabilities of graphics overlays, and I'll go back to Mark to talk about some advanced tips for getting good performance.
Okay, so they're pretty powerful, these graphics overlays. You can render and move around fairly large numbers of graphics, but we find there are some users who really like to try and push the limits here. So with 2D applications, I would say if you're sort of rendering and updating tens of thousands of points, then yeah, you'll probably be all right. If you try to push it beyond that boundary, and you haven't got particularly powerful graphics card hardware, then you may find that you've got some sort of refresh issues. So there are some tips that I can suggest that will help you to get over this, just to sort of push the barriers a little bit further with your graphics overlays. So, I mean, I acknowledged at the beginning that it is possible to have graphics overlays with mixed geometries. So you can throw in all your points and all your lines and all your polygons and try to sort of move them around. But that's not been particularly kind to your real graphics overlays. So some tips here to sort of improve the performance of your application is it's actually better for the software if you have a larger number of graphics overlays with a smaller number of graphics than it is to have one graphics overlay with everything thrown in. Further tips you can follow here is grouping your similar graphics together. So if you sort of put all your points in one graphics overlay and then your lines and your polygons in separate graphics overlays, you'll find that the software does render a little bit better. And you could also consider moving your static and your graphics overlays into separate graphics overlays. So if you've got something which is moving at a very high frequency, try to separate that out from the graphics that you've got that don't tend to move around. Now the graphics overlays have got two different rendering modes. There's static and there's dynamic. Cunningly named, you can probably guess which one you would want to use for things that actually move around. Actually, the graphics processing, the GPUs on these machines are pretty powerful. So I would say by default, the graphics overlays do render in dynamic mode, but if you find that you have got performance problems, then you can be kinder in your graphics card by moving it into the static mode. Now that just means that when you're zooming in and out, you don't get sort of nice animated symbols sort of moving around automatically, but it is a little bit kinder on your graphics card if you're finding that you've got low-powered hardware. But I'd say it's pretty rare that you would have to do that. You'd really have to be pushing the limits on some very poor hardware to achieve that. But just some things that you can try. Okay, so we've kind of covered a sort of a fairly broad range of functionality that's available in the SDK. I mean, there's lots more. There's things like routing and geocoding and all those other bits of functionality that you may be interested in. But I haven't covered it in this session because there's not enough time. And actually, these subjects are covered in the cross-platform runtime sessions that we have. So what I'm going to do now is I'm going to sort of jump onto a slightly dull subject of licensing. So when you're working with your bits of functionality in your software, you need to be sort of aware that the different levels of functionality, so the different bits of functionality fall into different licensing levels. So there are four. So there are light, basic, standard, and advanced. I'm not going to go into the details of what the differences are with those. So there's a website link there that you can go to, and there's also a product manager sitting over there who will be able to answer that question. He's just pretending that he's not there at the moment. So once you've established what the licensing level of your application is, you just need to choose the licensing method. So there are two ways that you can license an application to be deployed. The first of which is what we call the named user approach, and this is where if you are a user of an organization in ArcGIS Online, you can just use your application to log in to your portal, and it will just unlock the runtime capabilities of your application. Now, obviously not everybody uses ArcGIS Online. So a lot of people want to sort of use their own sort of ArcGIS server, or they're making a step back and it's an even more basic application. So the other approach we have for those users is where you can actually burn a license key into the application that will unlock its ability to be licensed every time you start the application up. Now those license keys are available in packs from customer services or your international distributor, and you'll get these in the form of a string. I'll explain this first because it's the easiest way of licensing applications. So you get hold of this string, for which I've cunningly hidden the important bit here. So you'll find that before your application does anything, you need to call this set license method on the ArcGIS Runtime environment class. So in this case, you can see before I even instantiate my JavaFX application, I'm setting the license so that I'm unlocking the capabilities of the application. So it's not running in a developer mode. So that's very easy. The other method that we have is, let's say, named user. So this is where you're actually going to be logging into your portal. So what I'm doing here is I've set myself up some user credentials, and I'm using those credentials to instantiate my connection to the portal. Incidentally, this code is just for demonstration purposes. I wouldn't encourage you to hard code username and password into your applications. That's very insecure. What I would encourage you to do is to use something like OAuth to authenticate yourself against the application. So I'm not promoting that as a pattern to log into a portal, although it does work. It's good for demonstration purposes. Okay, so I've sort of instantiated my portal class, and I'm sort of calling a load async method here. This is the loadable pattern coming in again. So I'm communicating with a web service that could be a little bit slow, especially if you're sort of using a big shared network like this. So once I've got that connection established, it's fired the done loading listener, I can then go in and I can use the portal class to get my portal info and get my license info. And this gets hold of a class that I can then use inside the set license method of the ArcGIS Runtime class. So that has sort of licensed my application and I can use it. Now, I was talking a few minutes ago about applications that work in an offline environment. So what use is that? We have thought about that. When you run, the way we've got around this is that you need to license your application by connecting to the portal, obviously when you do have a network connectivity. And then once you've got hold of this inflated license info class, you can turn that into a string, just to JSON in this case. And then you take that string and then you can actually store it somewhere safe on the device that you want to work with in an offline environment. And when you start your application up, all you need to do is re-inflate from that JSON string the license info class, and then you can pass that into your set license method on the ArcGIS runtime. So that enables you to be able to license your application when you don't have any network connectivity. And this license string will last for a period of, I believe it's 30 days. So as long as your application can reconnect to your portal every 30 days, then this is a valid offline licensing method. And if that's not the case, then you need to be burning the license string into your application if you can't do that reconnection. So you may be going off and to an exhibition to the Antarctica or something like that for 2 months, then you need to burn the license string into your application in that case. Okay, so we've done that not so interesting subject. We'll move on now to deploying your application. So as Java developers, you'll be using your IDE of choice to cut some code. In the lots of IDEs available, Eclipse, IntelliJ, NetBeans are sort of popular IDEs. IntelliJ is becoming very popular these days, actually, I find. I should reorder that list. And you'll write some code, you'll hopefully do lots of testing to make yourself an application that you'll compile up in a runnable jar. And that runnable jar you can then deploy into one of your chosen platforms, and it'll run inside the Java runtime environment. So here we go, we've got it working in Windows, Linux and Mac. Now remember, this isn't a pure Java application. We do need to make sure that we're deploying alongside that the binaries which are for the platform that you're running it on. So these binaries come with the SDK. So if you're running it in Windows, you need to make sure you've got the DLL file that we're going to JNI link into to run our application. And then, the same applies to Linux. You're going to need the SO file, and for Mac, you need a dylib. Actually, if you deploy your application so that you've got all three of those sets of binaries, you can have an application that you can deploy on any machine. So it'll work on Windows, Linux or Mac. It'll just work. That's what Java's all about. So considerations for writing cross-platform applications. Actually, it's pretty good. Generally, it does work. JavaFX, like Swing, its predecessor, they behave in a very similar way on all platforms. There are minor differences. So you can see there's a screenshot of a couple of applications I've got there from different platforms, and you can probably tell which one came from a Windows machine and which one came from a Mac. But these differences are good things. So the applications are styled for the platform that they're running on. But beyond that, it works in exactly the same way. The only thing I would encourage you to exercise caution with is if you're dealing with file paths. So if you wrote an application in Windows and you hard-coded a C:\/ style path to your file, it shouldn't come as any surprise to you that that might not work if you try that on a Mac or a Linux environment. The only other thing I just need to remind you of is that if you're writing an application that uses a local server, that doesn't work on a Mac. So the local server at the moment is only for Windows and for Linux. So I'm going to hand you back now to Tyler, who's going to take a slightly closer look at a deployment, which is good because I've forgotten how to talk.
All right, so for people who might want to look at all of our samples that are available, but they don't want to clone the entire repository, we offer a sample of your application that's distributed as a zip file that you can download from the developer site. And obviously that application makes use of the runtime. So if you unzip it, you actually have a pretty good idea of what a deployment structure might look like. So here I have the unzipped sample viewer. We have the application jar. Should be as easy as just double clicking it to run the application. We might have some local data that we're storing. This could be local tile packages, geoprocessing packages, etc. And then we have the native libraries that the runtime makes use of. If you got them with one of our Gradie or Maven plugins, you'll find that those plugins automatically downloaded the runtime libraries to the user's home.arcgis directory, and you can just copy those directly into your deployment manually or with maybe a Gradie task. If we look into these, the JNI libs contains those native libraries for each OS platform that we support. If you find that your users are only using one OS, you can slim your app size by removing the other operating systems there. If we go back and look in the resources, we have some folders. One is for doing optimized routing, so it will help the runtime with that. P data contains information on how to do spatial reference transformations and language translation, things like that. Shaders contains DirectX shaders for Windows, and then symbols contains symbol dictionaries for military symbol specifications. So that's one way of deploying your apps. There's probably many more creative ways that you can come up with. And if you have any questions about your deployment strategy, you can ask us after the talk.
Okay, so that kind of brings us to the end of the session. Before I open up the floor for any questions, I just want to advertise one more session this afternoon at 2:30. Tyler's going to be talking through how to write JavaFX applications. So if you're sort of familiar with Swing but want to sort of learn about how to do the equivalent inside JavaFX, we've got a fun session there. So any questions? Very quiet. It must have been. Aha, we do have two questions at the back.
Can graphic layers access polygons from operational layers to do shading, so you do like a work off map?
So the question is, can graphics layers obtain the geometry that's inside the feature layers? So yes, it can do. So in fact, that's how we actually do editing of data from feature services. So one of the capabilities we're bringing into the next release is a sketch editor, which enables you to be able to sort of change the vertices of a polygon. So the way in which we do that internally in our API is that you will sort of select the geometry, so it could be a polygon or it could be a line, and we actually read the geometry out and we draw that inside a graphics layer. And then what we do is we sort of put some edges where the vertices are that enables us to be able to sort of stretch and move the graphics layers around. So yeah, you're right. The classes, the geometry classes, so points, lines, and polygons, and there are other multi-points, etc. They are exactly the same classes that you're working with in your operational layers. Does that answer your question?
Yeah, I just wondered if the graphic layer can just essentially get a copy because they want it shaded or colored or something like that.
I think.
Overlaid.
Yeah, I think in that instance, if you want to be able to change the way your graphics, if you want to change the way your feature layer is rendered, you can actually sort of create a new renderer and apply it to the feature layer. So you don't need to sort of draw that data out and draw it in a graphics overlay. You can actually feed in a new renderer that will draw it in a different way. So that's using the renderer class. You can actually change that on the fly for a feature layer. So by default, the feature layer will render just using the way in which it's authored inside your geodatabase or your feature service, but you can override that in the classes. We've got a question here.
Yeah, I have two questions.
Okay.
The first one is when you are doing offline, the data is being downloaded and saved locally
Yes.
into a geodatabase.
Yes.
You are not referring to file geodatabase, right?
Okay, so the question here is sort of doing a comparison with file geodatabases and geodatabases. So the file geodatabase is a format of data which is quite old. So this is something that we've supported previously in ArcMap. Now the runtime can't natively read those file geodatabases at the moment, but I believe you can actually achieve that through local server. But the geodatabases that you're working with from feature services that you download are a new format. So if you kind of crack one of these open, you'll actually see that it's a SQLite geodatabase. So it is a new and much more efficient geodatabase format that and it actually enables us to be able to use this on mobile devices as well. So it's exactly the same format across all of the SDKs. So those two formats are different, and there's no compatibility between the two, but there are ways of reading them both inside the runtime. So file-based geodatabase, that's sort of an old format that, let's say, you can support that in local server. Your other question?
The other question is, in the graphics overlay, is not persistent. Is there a way to save that information somewhere?
Okay, so the question is, as you say, the data is not persisted. Is there a way of saving it? Not out of the box. There isn't a method to save all of my graphics there, but there's no reason why using the code you can't serialize those graphics and then be able to reinflate your graphics afterwards. So it is achievable, but you would have to write code in order to be able to do that. I think most of the classes have to and from JSON methods, so you should be able to deflate and reinflate those if you wanted to bring your graphics back on a different sort of session of the application. Any more questions? Okay, well, we'll end it there. If anybody's got any questions, just do come down and talk to us afterwards. Thank you very much.